This is instructional skill 6, and we are talking about writing fractions in order. This is page 24 in the textbook, and if you have not already done so, I would encourage you to do computation review pages 132 and 133. Write fractions in order. And before we get into that, let's look at this margin box to see what it's talking about. This goes along with that computational practice. I go in a little more in depth there, so that's a good one to watch before this. But recall that two fractions can be equivalent. In the computation video, I used the analogy of twins. While they are fundamentally the same, identical twins have the same DNA. They're the same thing, but yet they're not. So that's sort of the concept here. The internal value, the DNA of these fractions is the same. It's the same amount, but they look different. They're in different terms. And to illustrate that, they're using the fraction 5 out of 6 and 10 out of 12. And they've drawn those out. The first bar is marked into 6 equal parts. 5 of them are shaded. The bottom bar is marked into 12 equal parts, and 10 of them are shaded. And those are indeed the same amount. They're just expressed in different terms. Those are equivalent fractions. Here's another example. 1 out of 3 is the same amount as 4 out of 12. Fundamentally, they are the same, but they look different. They're in different terms. Then 3 out of 4 is equivalent to 9 out of 12. Just another example of that. And 1 out of 2 is equivalent to 6 out of 12. Both of those represent half of their respective bars. So we'll be using that concept as we go through these steps. The first question, or the example question, says to order the following fractions from least to greatest. In other words, start with the smallest one and build up to the largest one. And they show me that the answer is number 1. They walk me through how to do this process, but I'm going to walk you through it, and then we'll take a look at those steps. Those steps can be overwhelming sometimes. Sometimes, at least in my opinion, it's better to see the problem worked and then go from there. So here are the fractions we are comparing. We have 5/6, 1/3, 3/4, and 1/2. And the phrase that always comes to mind to me is you cannot compare apples to oranges. You have to have similar items before a comparison is realistic. And the same is true with fractions, and especially with the denominators of fractions. So I want to focus just on the denominators. And I'm going to bring those over. I am going to change colors because, and I think maybe I want to move that over just a little bit because I need a lot of space for this. You may even want a sheet of paper to do this on. So I have the 6, the 3, the 4, and the 2. And I'm just going to mark those in a box because I do not want them to get mixed up in the list of numbers I'm about to generate. And the name of what we're doing here is finding a common or like denominator. Instead of comparing apples and oranges and bananas and kiwis here, we're going to put everything in terms of the same denominator. And to do that, you use a concept called multiples. And I'm going to show you how it works. We'll move slowly. First thing I did, I pulled all of my denominators over here to the side, and I'm going to list the multiples of the numbers. I always taught my students to start with the smallest number in the list. And in this case, it's the 2. And I'm just going to start counting by 2. So I get 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and I'm going to stop there. I'm going to use an ellipsis to show that that sequence continues if I choose to, but I've gone as far as I need to. I've actually gone farther than I need to, but I want to show you something with this. So then I will move to the next smallest denominator and list those multiples. So I have 3, 6, 9, 12, 15, 18, 21, 24, and I think I'll stop there. Again, the ellipsis just says this would keep going if I wanted to do that. 4, 8, 12, 16, 20, 24, and we could keep going, but I like that 24. Then 6, 12, 18, 24. And so I will stop on that one as well. Now, I need to look at these 4 lines of multiples and mark the common ones. Okay? Common means that it shows up in every single line. So for example, the 6 is in 3 of them, but it's not in the line for 4. Okay? I see a 12. That's in this one. It's in this one. It's in this one. And it is in this one. So we could say that 12 is a common multiple. We could also say that 24 is a common multiple. And if I had chosen to continue this, I would find more common multiples. But I am looking for the least common multiple. What is the smallest number I can find that is common to all of these? And of course, it's easy to see it when it's written out like this. The 12 is smaller than the 24. So that is called the least common multiple. And let me just write that down right here. The least common multiple, or the smallest multiple they have in common. This is sometimes abbreviated as LCM, least common multiple, is 12. Okay? And that is found by this process that we just did. If you're feeling a little shaky on this, I would recommend watching this part again. Just go back to the beginning of the video until you feel comfortable with what I am doing. I'm sorry, I had to have a drink. My throat's getting dry. We could also say that 24 is a common multiple, but it's not the smallest one. All right, once you've found the least common multiple, you need to bring it up here to all of your fractions. Okay, so we are going to raise all of these up to 12s, up to the 12th terms. So to do that, we looked at this in the computation video. Let me get a different color so that you can follow what I'm doing. I know that 6 times 2 is 12. So if I multiply the 5 by the same 2, I would get a 10. 3 times 4 is 12, and 1 times 4 is 4. 4 times 3 is 12, and 3 times 3 is 9. 2 times 6 is 12, and 1 times 6 is 6. And once you have done that, now we're comparing apples to apples because all of these are in the terms of twelfths. So now I can find the smallest, which would be this one. The largest would be this one. So if you're starting with smallest, is that what they told us to do? Least to greatest, yes. So smallest, this would be the second one. This would be the third one. And then the largest would be the 10/12. So putting them in order, I would have smallest would be 1/3. I'm going to call that A. Then 1/2 would be B. 3/4 would be C. And 5/6 would be D. So here's the order I'm looking for. 1/3, 1/2, 3/4, 5/6. So this is the sequence we're looking for. And sure enough, that is what they have marked as the first option. This is not an easy problem. This is much easier for students who know fractions just intuitively. People who work in construction trades can usually do this without writing anything down because they know the logical application of this. For some folks, this is a tough thing to do. It is very tough if you struggle with your times tables because those are really what those multiples are all about. Okay, so let's go through the steps and see how they solved. The first thing they did was to compare fractions by finding common denominators. As a first step, write multiples of each denominator, and that's exactly what we did. We just circled ours instead of underlined. 12 and 24 are common to all the lists of multiples. 12 is the least, smallest common denominator. Then rewrite each fraction using the least common denominator. For each fraction, multiply the numerator and the denominator by the same number, the number that makes the denominator 12. We did that. Then step 3 is to order the fractions from least to greatest. Order the fraction according to the numerators of the equivalent fractions. So once you have them all in terms of 12, let me do a little bit of highlighting here. Once you have everybody in terms of twelfths, then you can look at your numerators to put them in ascending order. Then order the original fractions according to the order in step 3. So we would be pulling these fractions down to answer our question. Again, this is not the easiest skill in this book. Okay, let's look at page 25 and practice this just a little bit. We have concept, procedure, and application. At Sam's Coffee House, 47 of the 307 coffee beverages served on Monday were decaffeinated. Which fraction is the best estimate of the fraction of coffee beverages that were decaffeinated? I like this one. So we're going to go back to lesson 1 where we learned to estimate and apply those skills. So I have 47. Well, let me get a black ink so it shows up. 47 out of 307. But they want me to estimate. So 47 is awfully close to 50. And 307 is pretty close to 300. So I'm just going to estimate, take off one of my 0 pairs, and then reduce by 5. And this was in the computation review, how to do this reducing. So 5 into 5 is 1, and this is not an estimate, it's an actual number. 5 into 30 is 6. So the closest estimate would be number 4, 1 over 6. About 1 out of every 6 of those coffees that were served was a decaf. That would be mine. Okay, let's look at number 2. Lisa's favorite dish is her grandmother's cheese souffle. Her grandmother says that she must use about 3/16 cup of flour. Lisa has only 1/4 cup and 1/2 cup measuring cups. Which phrase best describes the amount of flour Lisa needs for this recipe? Would she use a little less than 1/4 cup? A little more than 1/4 cup? A little less than 1/2 cup? A little more than 1/2 cup? Or much more than 1/2 cup? So Grandma says that you need to use about 3/16 of a cup. So we can't go below 3/16. We would want to know what the nearest measurement is above 3/16. So I'm going to look at the 1/4 and the 1/2. And I'm going to raise those both up to 16ths. So in other words, let's level the playing field so that everybody's in terms of 16ths. And to do this one, I know that 4 times 4 is 16, so 1 times 4 is 4. 2 times 8 is 16. 1 times 8 would be 8/16. So which of these is nearer to the 3/16? Well, 4/16 is closer than 8/16. So I am not going to worry about this one. That one is bigger than what I need. So if she has 4/16 in a measuring cup, does she want a full 4/16? She does not want this to be full. She needs 3/16, which is just a little bit shy, a little bit less than 4/16. So I'm going to go with number 1. She needs to use the 1/4, the 1/4 cup, and she does not want to fill it. She needs to keep it below 3/16. So this would be 3/16. A little more than a fourth of a cup would be 5/16. A little less than half a cup would be about 7/16. A little more than half a cup would be 9/16. And then much more than half a cup would be maybe 15/16. So the one that's closest is number 1. That's a tricky question. I like it. I think it's very practical and very useful, but it is not easy. Number 3. Nigel is making bags of roasted mixed nuts for a concession stand. So far, he has made bags with the following weights. Which of the bags weigh 1/2 pound or more? Now, if you can do this mentally, I absolutely would. But if you cannot, this is one way to do it. So I would have 1/2, 2/3, 3/8, 7/16, and 1/3. So I'm going to list all of those fractions. And again, there are several ways you can do this. Because I want us to practice multiples, I'm going to go that route. Or am I? No, I'm not. We could do that, but I don't want to do that. Let's go at it this way. To be 1/2 or more, and I'm sorry if you hear music playing, it will stop very soon. To be 1/2 or more, the numerator, and remember the numerator is the top number, must be at least half the denominator. And I know when you first read this, it blows your mind. So let me show you what I mean by that. And this will always be true. This is a math fact that you can take to the bank. So let's put it right over here. All right, so let's apply this rule. The numerator here, 1/2, is exactly half the denominator. Half of 2 is 1. And that's why this fraction is 1/2. So this is a yes. It is 1/2 or more. All right, on this one, 2/3. What is half of 3? We know that half of 3 is 1.5. And that 2 is bigger than that. So this one, it is not that it equals 1/2. It is that it is more than 1/2, greater than 1/2. So this is a yes. What is half of 8? That is 4. So this time our numerator is not 4. It didn't make it to 4. So 3/8 is less than a half. Half of 16 is 8. That 7 didn't make it to 8. 7/16 would have to get to 8/16 to be a half. So it's less than half. Half of 3, we've already looked at this one, but we'll go ahead and do it again, is 1.5. And we only made it to 1. So this is less than 1/2. And the question is which bags weigh 1/2 pound or more. That would be this one and this one. You have 2 bags that reach the halfway mark. And I like answer 4. The 1/2 and the 2/3. Again, if you can do that mentally without having to write all this down, that is fine. And there are other ways to do it, but I think that's the easiest. I won't say the easiest, but it's the fastest way. Okay, a procedure question. I like these better. The longest dimension on Pamela's quilt piece measures 8 inches long. What fraction of a yard is this length? So you would have to know this fact. 1 yard in terms of inches, well, let's do it this way. We know that 1 yard is 3 feet, and each of those feet has 12 inches. So 1 yard is 36 inches. And Pamela's quilt piece is 8 inches. A yard is 36 inches. And so here is the fraction for us to set up. We have 8 over 36, and that will simplify. You can divide both the 8 and the 36 by a 4. 4 into 8 goes 2 times, and 4 into 36 goes 9 times. So that fraction in lowest terms is 2/9, or number 5. I like that question, but you do need to know that the yard is 36 inches. To the nearest 1/16, what is the length of the nail below? So we have to figure out which of these lines are 16ths. And I am suspecting the easiest way to do this is to count. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that is 16 16ths, or 1. 17, 18, 19, 20, 21, 22. So that is at 22 of those 16th marks. And that is an improper fraction. So I'm going to say 22 divided by 16. That's 1 time. With 12 minus 6 is 6 left over. Have I done something wrong? 16, 17, 18, 19, 20. No. Okay. 1. Oh, I'm sorry. I had a brain lapse there. That equals 1 6/16. Okay. You could confirm that by counting up to this 1 right here. And then there's 1, 2, 3, 4, 5, 6, 7 spaces over, or 6 of those lines. 1, 2, 3, 4, 5, 6. 1 6/16. Unfortunately, that's not one of my choices, but I'm almost there. If you reduce 6/16 by 2, you will get 3 8ths. So 1 3/8 is one of my choices. And I like that one for number 2. 1 3/8 inches. Application. As part of a track workout, 5 girls ran as far as they could for 10 minutes. The distance each girl ran is recorded in the table. Who was the fastest runner? So they ran for 10 minutes. Who got farthest? Who went further than the other 4? So for this one, we are going to have to get a common denominator. And I'm going to try to squeeze it in right here. Let me move this. Oops. Don't want to move all that. Sorry. Let's move this over here out of the way so that I have as much space as possible to work here. All right. So we have 1 1/2, 1 1/4, 1 5/8, and 1 3/4 as mixed numbers. And then we have Tiffany, who ran 7/8 miles. Now, Tiffany ran further than I could, but she did not run as far as the other 4 girls. She did not make it to a whole mile. So I am not going to factor Tiffany into my math because that's just one more person I have to figure, and I know it isn't Tiffany who was fastest. So I'm going to use 1 1/2, 1 1/4, 1 5/8, and 1 3/4. And I am only going to pull the fractions over. So I have 1/2. Actually, because I don't have a lot of space, let me do this. There is another way, and I'll show you this in just a minute. But let's do it the way they want me to first. So I have a 2. That's my first denominator. I have a 4. I have an 8. And I have another 4. So we don't have to write that one. We've got the 4 in there. And we start with the smallest one. So I get 2, 4, 6, 8. I can stop because I already see my common denominator. The 4, I would have a 4 and an 8. So I get that 8 in that row. It's here and it's here. And we know it's here because that's the number we're looking at. So this is your lowest common denominator. Each one of them will work with that 8. So let's use the 8. We have a 1/2. We're going to raise that up to 8. So 2 times 4 is 8. 1 times 4 is 4. So Amber was 1 4/8. And then we have the 1/4 that we're going to raise up to 8ths. And that is 2/8. So Brianna was 1 2/8. Then we have a 5/8, which is going to be 8 times 1 and then 5 times 1. So Lana was 1 5/8. And then Nicole was 3/4. So we raise that up to 8ths. And we're multiplying by 2. So Nicole was 1 6/8. So of these distances, who ran furthest? who got the farthest distance-wise. And of course, that would be Nicole. So I like answer 4 here. And I told you I would show you another way. I'm going to do that. This is actually the way that I learned to do these. My mother thought I was cheating because when she would sit me down in the evening to do homework while she cooked our dinner, and I was doing fractions, I had to get common denominators, and I was doing it really fast, but I was getting the answers right. And so she wanted to know how I'm doing it. How was I getting it so fast? And here's what I was doing. My father had taught me decimal equivalents because I was with him a lot in his garage, and I learned really quickly that 1/2 is 0.5. So I was saying this is 1.5 or 1.5. A fourth is 0.25. This one was a little bit harder, but I did learn, and let me check one thing before I tell you this. I believe the calculator puts a leader 0. Hang on a second. And actually, it doesn't matter on this one. Sorry, I'm thinking of 7/8. Bear with me. This one is 1.625. Then 1 3/4, that's 1.75. And here's where I need to look at how the calculator does it. I'm pretty sure it does the leader 0 if you were using the calculator, and it does. So this one would be, I would have called it 0.875 because that's what I learned, but the calculator will throw the 0 in there for you. And then mentally, I knew that I had to level out those places. And then I could tell you which one of those was the largest. And again, it is Nicole. So what I was doing is transferring everything to decimals, doing the math, and then transferring back to fractions. If you are able to do that and you're comfortable doing that, that is absolutely an alternate way to solve these. But they wanted us to get common denominators and go through that. That is another good way. Just depends on what comes easiest to you.